since we substitute in this equation here, the exponential, and the future value equals A, 7050. There's U, e to the U, so it's e to the minus 0.08 t. F of x, which is 1, and dt is minus 0.08. And of course, this is going to go between 0 and 5. So let's go back up here. The future value equations will be given to you on your reference sheets for the final, so don't worry about memorizing them. So the future value here is going to be 7050 divided by minus 0.08 e to the minus 0.08 t between 0 and 5. So let's see what 7050 divided by minus 0.08 is. And that is actually a high number, 88,125 minus now what I'm going to do, since I don't have to, since the minus 88 is a constant, I'm going to factor that out when I do this. So I'm just going to take the e to the minus 0.08 times 5 minus e to the minus 0.08 times 0. All right, so this remains outside here, no loss. And e to the minus 0.08 times 5 is what? Is minus 0.4, correct? So e to the minus 0.4 minus e to the 0. So that's going to be minus 88,125. And let's figure out what e to the minus 0.4 is, okay? That is 0.961, and that is 1. So 1 minus 0.961 is really 0.039 minus, so it's minus 88,125 times minus 0.039. And what do we get? We get that our future value is 88,125 times 0.039, or 3439. Notice a minus times a minus becomes a plus. Now, in the problem, I don't know if they give you that as a thing, but we're selling 0.3439, selling printing presses. So printing presses are kind of expensive, so I would imagine that this is like, I believe this was in hundreds. So we have to add 2 more zeros on here. But you get that from the problem. Anyway. All right, so that is your future value if you invest it at 7% for 5 years. All right, let's go on and introduce something different now. There's always a present value or a future value on the test. But I want to go into something else which is very important economically and which should be taught in this course. Okay, so I want an economic measure of the inequality of the equality or inequality, one or the other, equality, I can't spell it today, of income distribution in, let's say, County A. All right, so what do we know about County A? County A, this is called something called G. You measure this, it's the Gini coefficient. And that is a measure of income equality. And what they found out, they had a past, gave them a G equals, let me look at it. 0.43. And that was in 1991. Now they want to find G in 2006. Well, let's look at a formula for G, which they give you. Once again, you will get this. And what is X and what's this? Well, L of X is called a Lorentz function. It is the equality function for any county, for County X, County A, at time T. So let's see what this means here. Let's take a graph here. Let's just call this Y. You can also say this is equal to Y. Now, let's look at a line here. Y equals X. This Y equals X is at a 45-degree slope. So if you have $2 here, you're going to have $2 here. Any point on here, income is equally distributed between these two. What a Lorentz function does, like for example, it could be a quadratic. The area of this Lorentz function will measure the difference between how far the county is from the ideal income distribution when Y equals X. This pen is going to
the happy hunting ground.
Okay, so this line is, let's draw it like this. That's our ideal. We want everybody to have the same income. Right. Okay. All right, so what this country decides to do is to have a little tax legislation. Tax the rich, don't tax the middle class and the lower class, because they want to improve their distribution. So what would be an ideal distribution? Let's look at our formula more closely. So what's an ideal distribution? Ideal is when G equals 0. Why? Let's look at this. when g equals 0, x is that, and L of x also equals x. Zero dx is 0. So when g equals 0, the Lorentz function completely overlaps the y equal x 100% distribution function. So that's your goal. But let's see, what is the Lorentz function in 206 for this county? Okay, let's look at that. Okay, for this county, we're going to get 2.4x squared, x to the 4th, minus 3.3x to the 3rd, plus 2.1 x to the squared, minus 0.2x, and this is after the taxes. 1 year after the taxes, after the tax increase. So before that, this was different. Obviously, it's not y equal x, so it's not going to be 0. So let's see what happens here. Let's substitute in our integral 0, 1, x minus 2.4 x to the 4th minus 3.3 x to the 3rd plus 2.1 x squared minus 0.2x dx. Okay. So what we're going to get here is x minus 2.4 x to the 4th plus 3.3 x to the 3rd minus 2.1 x squared plus 0.2x dx. All right. Let's clean that up a little bit, subtracting the x's and doing everything separately. G is actually going to look at this, like this. Okay, it's going to be integral 0, 1 minus 2.4 x 4th dx plus integral 0, 1 3.3x to the 3rd, okay, minus integral 0, 1 2.1 x squared plus 0.6, I'm sorry, plus 1.2 x 1.2x. This should be dx here. Sorry about that. This should be dx. All right, so I'm not going to go through it. This is the simple power rule. So what you're going to get is 0.48 x to the 5th minus plus 0.83 x to the 4th minus 0.7 x to the 3rd. By the way, this is supposed to be x squared. Oh no, that becomes x squared now. I'm sorry, it's my fault. Plus 0.6 x squared between 0 and 1. Well, I'm going to put 1 in here. When I put zeros, they all become 0. So all I have to do is do this. And when I add it up, my Gini coefficient becomes equal to 0.50. And this is in 2006. How much time do we have?
We're just at 15 right now.
Okay, we'll come back and analyze it.